This is Team Trash Pandas giving their presentation on the test results database. And Anna will take it away. My name is Kelli.
Hello, my name is Anna Kawasaki. First, I'm just going to give a high-level description of this project, which we'll go into more detail later. So basically, our project was collecting test data from various PacStar products, formatting that data, and then inserting that data into a database with the ultimate goal of being able to track their test results and use that tracking to analyze long-term trends to report to higher management.
Hi, my name is Pham. I'll be in charge of doing a little quick demo on how the program works. So our program is a console application that can be run in the console, and you're going to need to be able to have these arguments as the required ones is definitely test path, and then depending on what sort of test you run, that will go into detail later in the slides. You would pick accordingly, and as well as has some additional options as well. And here's a quick example of the UIA test run. It will go by pretty quickly. And you can see at the bottom that it closed the connections to test results, which means that it's successfully inserted stuff, if anything, to be inserted into the database. At the end of the program, depending on what files you give it, it will create either a CSV sanitization report, JSON sanitization report, and a TRX sanitization report. But for the end of the program report will be generated regardless of what tests you are giving to the program. And I'll be passing it on to Anteny.
Hi, I'm Anteny Erdman, and I'm going to cover the overview and our audience. So there's a little bit more in-depth overview. What our exact goal here is to do is extract items from these tests documents that PacStar cares about, which is important because it's tens of thousands of lines of information, and that's very unrealistic for having a person go through it. We then transform that data to fit into the database by removing unwanted characters and confirming that the data is correct, making sure there's nothing trying to attack the database and so on. And then we load the data into the database. And we want to make sure that's not already there first, so we do that as well. Who is this for? Well, it's for the test operators at PacStar. We want them to be able to run this whenever they run a test, so that way the data can go straight to the database. It's also for the software engineers at PacStar. They need to be able to maintain and add to this program in the future. And then I'll pass it over to the next person.
Hi, this is Anna again. So the first feature that we implemented was the soak test extractor. This involved importing test data from a CSV file. This test data include metrics and their results. That data is sanitized, and then we also imported metadata from a JSON file. This file included any data that wasn't included in the CSV file, and that includes things like the test user, the software version being used, and the operating system, among other things. That data is then also sanitized. After that, the data is parsed and organized into lists of entities that correspond to database tables. Those entities finally are inserted into the MySQL database, where it's checked for errors and duplicates.
Hi, I'm Samantha King, and I will be going over the UIA extractor feature. The UIA extractor is used to import, parse, and insert data from a TRX file. This extractor first reads in data from the TRX file, then the data is sanitized by removing any unwanted special characters. Once the TRX data is sanitized, the data is parsed using the NuGet XML serializer package. The serializable classes store values from each element in the TRX file. Once all the data is properly parsed, the data is then inserted into the MySQL database. As the data is being inserted into the database, the insertion methods check for any errors such as duplicates or null values.
Hi, my name is Nathan Bui. And for the data sanitization, we have done the sanitization for the JSONs, CSV, and TRX files during the extractions. We did that by sanitize the special characters to avoid the cross-site scripting attacks and mobile injections. And we only allowed to use the ASCII characters to avoid the homoglyphs attacks. And we also validated and sanitized the user input from the command line by validating the file path to avoid the path attacks. And we are only allowed to use some special file types to avoid the injections and SSH attacks too. And finally, we prevented the SQL injections by using the SQL parameters. And we only use the sanitized data for the database insertion.
Hello, I'm Tanner Mestas. I worked on the main program UI. What this does is determines the functionality that we want to run based on the file type given to the program by the user through the command line options. These command line options aren't just for file paths either. They do like the status report and whatnot. There's a few other things they're used for also, but those are implemented using a library called command line parser. And basically what happens is the flow of the program is it's determined which to use, the soak tester or the smoke UI test data importer. It determines which one of those classes to use based on the file path given. Also, that library that I mentioned provides a help menu when ran with incorrect or no arguments.
And this is Antony again, covering the status reporting. When we have the status reporting active, it allows the program to output messages about the program's current state and includes such messages as when it starts inserting section of the test report to the database, when it finishes doing so, if it finds any duplicate items, when items are saved, so on and so forth. And by not including this argument, it just simply hides all of those messages so that it can be used for debugging or ignored if the user doesn't need that information.
So recently we also added a soak testing or unit test for the soak test and data sanitization classes. This is just a regular C# unit testing project. In the soak test tests, it validates that the insertion to the database is working, as well as the extraction of data from the CSV file. And for the data sanitization, it verifies that it's like grabbing the right characters out of strings and whatnot, and yeah, verifying that the functions are working the way they should. This is a overview of the architecture. So like I mentioned before, we have our unit test project, and then along with that, we have our main project. So I'll focus mostly on the main project since the unit tests just validate the main project. We have soak test data importer, smoke UI test data importer, and sanitizer for the 3 main things in the main project. So the soak test data importer handles the parsing of CSV files, so it extracts the data from those files. It also does that for JSON files. And after running the sanitization, it'll insert the sanitized data into the database tables. The same thing happens with the smoke UI test data importer, except it uses a TRX file. So this will parse the TRX file, which contains both the metadata and the test data, and then we'll perform the insertion into the database tables also. And then the sanitizer validates file names and types and sanitizes the data after extraction before insertion.
It's Anna. I'll be talking about our development process. So we primarily used the Jira board to delegate tasks and track task progress. We divided our time into 2-week sprints to provide timely structure. At the end of each of these sprints, we had demos with our sponsor in order to present the work we completed during that sprint and gather feedback so we can adjust our work accordingly. We had stand-ups 2 times a week for team and individual check-ins, as well as to analyze the backlog and decide our next steps. In Jira, our features were organized into epics and stories in a hierarchical fashion so that we could prioritize and plan features and requirements effectively. So here's a quick breakdown of the major steps that we took, as well as the time and effort we put into them as a percentage. So the soak test extractor was 30%, sanitization 20%, smoke UI test extractor 35%, program UI 5%, QA work 10%. So most of our time was spent on the extractors, mostly on the UI test extractor because it was using a TRX file, which was unfamiliar to us, so that required some additional research. We also made some adjustments to our process along the way, including adding QA work just to make sure everything was going smoothly and that we were hitting all the requirements. We also added additional backlog grooming and story discussion to complete tasks more effectively.
Samantha again here, and I will be going over responsibilities and contributions. So for the duration of this project, all team members contributed to a variety of features. And these are the features that each team member primarily focused on. So Anna worked on the soak test extractor and unit test. Anteny worked on documentation, main program UI, and the end of program report. John worked on the end of program report and the soak test extractor. Nathan worked on sanitization. Myself, Samantha, worked on the UIA extractor as well as sanitization for the UIA data. Tanner worked on the main program UI, the soak test extractor, and unit tests. Kelli, our team lead, handled all the setup, the facilitating, and documentation. And some shared responsibilities included preliminary research before starting work on a feature, quality assurance and performance investigation to ensure there were no bugs and features were performing properly, as well as code cleanup.
This is Nathan again, and for the unexpected events, first of all, we have the code conflicts at the end of the development because we have implemented the unit test, and that requires to have the file structure and data structure changes. So it caused the major code conflicts for every team members, and we have resolved that one by reaching out to the responsible members and resolve the conflicts one by one. The another unexpected event was the additional requirements from the sponsors. So they want to have some additional features that we have not think of and didn't in our initial plan. So we have overcome that by reprioritizing all the feature implementations and focused on the requested features by the sponsors.
It's Kelly again, the team lead. So towards the end of the project, I went back to our sponsors, Brad Wheeler and Mike Hatch, and asked for some feedback. I'm not going to read all of this to you, but I feel like the most important one from Brad is, I feel as though I went into this project with a fairly clear head. College students working on a project they had no personal connection to, and using unfamiliar tools. It could have been a disaster. Instead, we're getting version 1.0 of software that we've been trying to get in place for over a year. That's downright impressive. And then I also went to our other sponsor, Mike Hatch, and his most important feedback was, as a manager and someone who's been working with senior developers for a long time, I was able to temper my overzealous expectations and see the great work the team has been doing. So overall, our sponsors are very happy with the work that we have done.
But I, Antony, am here to discuss some of the lessons we learned. One of the biggest things was learning what it's like to be in an industry environment. We worked very close with PacStar, and we tried to make it as if they were our customer and interact with them in that fashion. Also, due to Kelly being a intern at PacStar, we were able to form our team and work as if we were simulating a PacStar team, which gave us more insights into how that actually works and operates in a real life fashion. We also learned time management is important. If a task takes longer than expected or a new task gets thrown in, it causes a cascading effect that pushes back everything. We also had to constantly wrestle with expectation versus reality, as well as quality versus quantity, especially at the beginning when we were trying to decide what exactly the project would be with them. We had to question if adding that extra feature was realistic. A feature may seem small, but implementing it may not be as that small of a task. Also, if we added more features, then the features we already had wouldn't get as much time and as attention as they would otherwise. So we had to go back and forth between these, and they were really good teaching moments throughout the program, throughout the process.
Hi, it's John again, and I'll be going over the extended demo that we have. Here you can see the soak example run, which takes quite a bit of time longer than the UIA example run. So we're not going to sit here and wait for it to finish. So I'll be going over the sanitization report on the next slide. So here you can see an example of the sanitization report. You can see the original and this versus the sanitized in both of the lines. And in the next slide, you can see the end of the program report. This is also another snippet since it's honestly the file is too large for to capture it all. So a snippet you can see at the top, you can see test type UIA, the file path of at least in this case, the TRX. And then, as a UIA, there's no meta file, so it is left blank. And as you can see, for example, the test user table has had one attempted inserts and it was a duplicate. Then more notably, halfway down the screen, you can see